This is another example that we look at another vector, in this case another direction, where we see in Miller-Bravais indices in HCP crystal lattice, we see that this vector, this direction starts from this corner and it goes all the way to the other corner, basically in cross diagonal over whole crystal lattice there. And of course, again, like in the previous example, we've seen that it doesn't start in the origin, but as we did previously, we can shift the vector, move it, so the tail of the vector, or the direction, is in the origin of the coordinate frame. It's much easier for me to move the vector than to move the coordinate frame. So we can see that at this moment, and as we did in the previous, we work initially with a 3-axis coordinate frame where we use only A1, A2, and Z, and then we convert to the 4-axis frame that will basically clarify clearly that direction in this hexagonal system. So after we moved, we try to find those for 3 axes. What are the coordinates or the projections? And when we see this, again, it's interesting to see that when we move here along the A2 axis, along the Z axis, we can see that when we move with 1 unit there, here along the Z axis, this vector will touch the Z axis on the half along the C, this direction, which would have been 1C. So it just rises only half. So if after I'm moving there, if I run from the center all the way to this corner with an integer of 1, from that corner here all the way going upwards, I rise with only a fraction of a half. The tip of the vector is there. So when we are projecting, again, I want to still stay in here. We have the options to use all the way there. So in this case, if I will have the objective to move there all the way down, I will end up with 2 units of A there and a unit of, along the Z-axis of C. But I also have the options to keep, instead of 2 and 1, I also have the option to keep 1 and 1/2 here. Either way would work, it doesn't matter. So however is convenient for you. I selected here only to go with 1 unit there and half there along the Z-axis. And if you look here on this projection, you see that this vector, when you project on the base, it doesn't have anything along the A1 axis. So its coordinate of the tip, it will be 0 along. It doesn't project. It's all A2 it projects along the A2. So I will have 0 for A1, 1 for A2, and 1/2 for Z-axis. So, and then we proceed. These are the 3 U, W, V, and W, all capitals, and we proceed to replace them in those formulas, and then we calculate, and we end up with this fraction. So we have to reduce them, and when we look here, we have the smallest common multiple for this situation is 6. So that means the sum of the fractions need to be multiplied by 2, or others like this one, the last one, needs to be multiplied by 3. So we have a common factor of 6. So you can see that I end up in this case where I remove that 6 outside, and you see that we end up with -2, 4, again -2, and 3 in here, because that is multiplied by 3. So now we remove the commas, and now we are putting the bars and everything on top, and we put the brackets, everything, the brackets. So these are the Miller-Bravais indices for this direction. I hope this helped, and I also hope you have a beautiful day.